Hello, Intro to Stats. Welcome to section 5.7, Normal Distribution Calculations. In this section, we are pretty much putting together everything we've talked about so far with normal curves, and we get some really exciting news. It's not really that exciting, but in terms of this class, it is, I guess. But the really exciting news is that we can solve problems that involve normal distributions, even if they are not on the standard normal curve. Okay, so what does that mean? We've got a couple general steps, and I'm going to go through each of these steps. Now, you don't necessarily have to write out all the work for each of these every time, but there's going to be some things that are definitely helpful. And so I'll give you the general things and we'll work through it together. So often, state express the problem in terms of the observed variable x. So basically, write out what you are trying to find. Draw a plan, meaning make a curve of that distribution. So our curve, our normal curve, and shade the area of interest. So let's say it's what's the chance that we're going to get less than this value? In our do, we're going to perform calculations, which is two steps. We need to first standardize x, meaning make x, whatever this thing is. Let's say we want to know what's the probability that we get less than a 25% on a test. Hopefully it's a very small chance. We first need to change that 25% to a z-score. So standardize that variable and then restate your problem in terms of z. And then we use table A, so that big table at the back of your book, to find the probability. And then last but not least, write a conclusion. So make one final statement in the context of the problem. I'm going to skip to the next slide. So if you really want to write down all these things, I would pause the video. But if you just wanted to listen, that was totally fine too. The first problem today kind of reminds us of a homework problem, potentially, if you were paying attention. In the 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. Assume that the distribution of his first serves is normal, with a mean of 115 and a standard deviation of 6. About what proportion of his first serves would you expect to exceed 120 miles per hour? So I'm going to do all four steps there just kind of to emphasize the process for you all. So our state is that we want to find the proportion of Nadal's first serves that exceeds an extra E in there, that's okay. That exceeds 120 miles per hour. Now, what we are looking for in symbols is the probability that his serve x is greater than 120. That's what we're looking for. So that's our state. In our plan, we need to do a couple things. We're going to draw a picture of our curve. So it's a normal curve. It had a mean of 115 and a standard deviation of 6, which means here we'd be at 121, 127, 133, and I'm not even going to do all the numbers below because I don't really need it for this problem. But I am then going to shade. So 120 would be a little bit below 1 standard deviation. Now we're looking for greater than exceeds. So this is what we are looking at. Here is our shaded picture. Again, we had a mean of 115 and a standard deviation of 6. State plan. Okay, now we have our do. We need to standardize this score. So we need to figure out exactly how many standard deviations above or below. We see that it's a little less than 1, but we don't actually know without solving. So I'm going to use my formula for a z-score. Value minus the mean over standard deviation. Or in this case, the value, which is 120, minus the mean, which is 115, all over the standard deviation of 6. And I get 0.83, or a z-score of 0.83. So now, technically, instead of finding the probability that his serves are greater than 120, I am looking for the probability that I get a z-score greater than 0.83. Now notice that these are technically the same thing, they're just different context. This is in the context of the problem, this is in the context of our standard normal curve. Well, what do we do now? We go to table A. But the issue is the table A gives us the area to the left. So I just need to remember that when I calculate this. Here is my standard normal curve, 0, 1, 2, 3. And again, I'm looking for 0.83, which is right here. I am interested in this area. If I go to table A and I look at 0.83, which I'm doing right now in my book, hopefully you are too. If you don't have your textbook, remember there's one online, or you can always just Google table A. But I'm looking for my table A. I'm following down on the left side 0.8 and on the top 0.03. And I see that the area to the left, oops, I didn't want to do that. The area to the left, this area, because that's, remember, what table A gives us. This area is 0.7967. So if I really want this blue area, what am I going to do? Well, I know that the total area is 1, so I'm going to take 1 minus 0.7967 to get a final answer of 20.33. 0.2033. And this is my answer, which makes me excited and means that we can write a final conclusion. Again, I'm doing all 4 steps here. It's not totally necessary. Every time you do one of these problems, it's just kind of emphasizing everything that we are doing. So 20.33% of Nadal's first serves, serves. Oh wait, wow, I'm really dumb, sorry. We're just gonna ignore that. Serves exceeds, what was it, 120 miles per hour. Oops. Ta-da! And we are done. Let's try another one. What percent of Nadal's first serves are between 100 and 110 miles per hour? For this one, I'm not going to do all the work. I'm not going to do the state plan, do, and conclude, but I'm going to do some of it. We are finding the probability that his serve is between 100 and 110. And so we need to figure out what each of these is as a z-score. I'm going to draw my picture though, just to kind of emphasize what we're doing. Here's 115, the mean, and that means this would be 109, right? 115 minus 6 is 109. This is 103, and this would be 97. So here, if I'm looking for 110 is right here-ish, and 100 is right here-ish. I'm looking for this shaded area. Well, I first need to find 2 z-scores. So for this one, my z-score would be 100 minus 115 over 6. And hold on. And this z-score would be 110 minus 115 over 6. On the far left side, we're getting a z-score of negative 2.5. On the not far left, but still to the left of the mean, we're getting negative 0.83. So then again, technically, what we are looking for is the probability that I have a z-score between, sorry, I put the z too far over. The probability that I have a z-score between negative 2.5 and negative 0.83. All right, and so to do this, we're going to do what we've done a couple times. I'm going to find the area to the left of negative 0.83, area to the left using table A. I'm going to find the area to the left of negative 2.5, area to the left, and then we're going to subtract those two. So when I go to my table A and I look for negative 2.5, I'm getting 0.0062 as the area to the left. And when I go to table A and look at negative 0.83, I'm getting 0.2033, which matches up with the previous problem we did. And so if I want to get, again, I'm just going to kind of re-emphasize what we just figured out. Here's 1, let's say this is negative 0.83, and here's 2, negative 2.5. I want this. Remember, 20.33 is all of this area, and the 0.062 is just this little guy. So if I want to get the blue, I'm going to take 20.33 minus 0.62% to get a final answer of 19.71% of Nadal's first serves are between 100 and 110 miles per hour. Nice job. Another type of problem we can do is similar to the ones that we've seen before, where we're given a probability and we need to find the value. So according to the CDC, the heights of 3-year-old females are normally distributed with a mean of 94.5, mean 94.5, and a standard deviation of 4 centimeters. What is the third quartile of this distribution? Ooh, we haven't heard that word third quartile for a while. Third quartile means the value that has 75% to the left. So I know that the mean is right here, 94.5. And I know that there's 3 standard deviations. I'm not even going to draw that standard deviation here because I don't really know 94.5. But I'm looking for Q3, which is probably going to be somewhere around here. Specifically, we do know that the third quartile has 75% to the left. All right, so to find this, we're going to start by going inside table A. I'm going to look on the inside, and I'm going to find the value that matches closest with 75%. So I'm seeing 74.86. I'm also seeing 75.17. Honestly, either of those is going to give you a close enough answer. I'm going to pick the z-score. That gives me 75.17%, which is 0.68. 0.68. So a z-score of 0.68 has 75.17% to the left. So that's what I'm going to choose. Now, this is a z-score. I don't actually want a z-score. I want the actual height. So what do? Well, I go backwards in my z-score formula. Here's what I know. A z-score is equal to a value minus the mean over the standard deviation. In our case, I have a z-score, so 0.68 is equal to, I'm solving for x, but I do have the mean, 94.5, all over the standard deviation of 4. And now we're really just doing basic algebra, and we are solving for x. So I'm going to multiply both sides by 4. And then technically, I'm going to add, well, okay, I would get 2.72 is equal to x minus 94.5. I move 94.5 over, and I get x is equal to 97.22 centimeters. Now, we ask ourselves, does this answer make sense? I would expect my third quartile to be greater than the mean. The mean is 94. This value is 97. Okay, that feels good. So I'm feeling pretty happy about this. Everything we have talked about so far can be done on your graphing calculators. Now I will say 2 things. The first is, if you don't have your graphing calculator at home with you, don't stress. You can definitely use table A, and that's fine. So if you don't have your graphing calculator and you don't want to listen anymore, okay. goodbye, and I will miss you. But if you do have your graphing calculator, please grab it because I want to show you a couple of really important commands that will help do our work more quickly. So the first one is normal CDF, which the C stands for cumulative. Normal meaning it's a normal curve. This is found if you click the second key, which is the top left key on your calculator, and then go over to VARS, which is kind of next to the clear button, and then the second option is normal CDF. If you go here, it's going to ask you, and depending on your calculator, it's either going to literally ask you by having these words, or you're just going to see like this, and you'll have to put commas. The comma, if you need a comma, is right above the 7. Okay, but if your calculator prompts you, it's going to ask for the lower bound, the upper bound, mean, and standard deviation. So in the problem that we did at first, it said find the proportion of Nadal's serves that will be above 120. So if I draw that again, we're looking for above 120. Well, our lower of the shaded region is 120, and our upper is just a really big number. If there isn't actually an upper, just make it a big number. So I did 9,999, a mean of 115, and a standard deviation of 6, and it spits out my answer, the same answer we got before. Yay, that's very exciting. We can do this with this problem as well, between 110 and 100 and 110. I would just change 120 and 9,999 to 100 and 110. I don't have a little screenshot of that, but definitely try that. Then another one that will help would be the previous problem we just did. If you go back to that second VARS, the third option, inverse norm, helps us calculate this. So for inverse norm, it wants you to put percentile, or another way would be area, in decimal form. So in our last problem, we'd put 0.75 for inverse norm. This is going to be the reverse of what we just did, 0.75. A mean, in the previous problem, our mean was 94.5. 94.5, and a standard deviation of, what was it? A standard deviation of 4. So I'm doing this right now with my calculator. I, of course, wish I could show you it on the screen, but I can't, and I'm sorry. But when I click this, I get 97.19, which we did a slightly different answer. We got 97.22, but I would argue 97.19 is very, very close to 97.22. The difference is really just what z-score I picked. Remember here, I picked a z-score that technically had more than 75% to the left. Your calculator is finding the perfect answer. So anytime you look at a solution, let's say that you calculated something and the answer key said 96.3 and you got 96.2. Honestly, both of these answers are totally fine. All right, I know that was a lot, but if you have questions, please let me know. And actually, you are not going to have a video on Friday because this was it.